Now, the example you see here may look familiar. When we introduced Cassandra joins, this was the result of our optimization process. We said, hey, we were done, it's running much faster. It turns out, though, there's actually more we can do. Let's look quickly through the code again, just to get the example in our heads. We're going to start with a local statically initialized list containing two actors, Johnny Depp and Bruce Willis, and parallelize that, make it into an RDD. Then we're going to join that with the Cassandra table, movies by actor. And we're using join with Cassandra table, so the join is being done inside the connector, which is great. However, we might be getting our partitioning wrong. Let's take a look at a diagram that illustrates what's happening. Now, getting outside of our movie paradigm for a second, we see three nodes here. Now imagine we have three actors, Bruce Willis, Johnny Depp, and Emma Stone. And we made a collection out of them, we parallelized it, made an RDD, and that RDD gets partitioned. We don't really know anything about how that RDD is partitioned, though. We'll probably see Emma on one node, Johnny on another, and Bruce on another. When we join that to the Cassandra table, those elements in the actor name RDD are likely not going to be on the same nodes as the partitions they're being joined to in the Cassandra table. We haven't done anything to establish a relationship between that, so occasionally we might get lucky and we might see the source RDD being on the right node, but usually it won't be. So in the optimal solution we see over on the right, you'll see the Bruce record from the source RDD is on the same node as the partition that has Bruce as the key. Likewise, Johnny is on the same node that holds that Cassandra partition, and Emma, that RDD record in the source RDD, is on the same Cassandra node that holds the Emma partition. It's a lot more efficient this way because we don't have to move data across the network, and we'd really like to avoid that if we could. The trick to getting this done is to use the repartition by Cassandra replica transformation. This is going to kick off a partition of the RDD that you call it on, but it's going to partition it to put the records on the nodes where they belong, where if they're going to come in contact with a Cassandra table in a future transformation like a join, they're already going to be in place and we'll have less network traffic to do down the road. So if there are several joins to do with this, we've already done the partition and the shuffle, we won't have to do it again. And here's what the code looks like. It's really just a small tweak on that initial collection that we parallelize. After we parallelize it, we repartition it by Cassandra replica. Of course, we have to specify the table because Cassandra is going to need to know what's the partition key structure that we're partitioning by, but we do that and that shuffle takes place. Afterward, we're able to join that with the Cassandra table and that's going to run faster.